So I have the tough job of keeping you guys from happy hour. All right, and I have 45 minutes, maybe less now, and 45 slides. So here we go. All right, so Anurag Tandon, I'm in the product management team, work on Neo4j Blue. That's going to be probably about half of my topic here today. The other couple parts that I'm going to start from would be, just a couple of takeaways on what makes Neo4j something different from what you've experienced. And we've heard a lot about that today, so I'm not going to spend too much time on this piece. Certainly not a sales pitch at all. And so if you guys have questions, the next set of slides is just meant to be for you to have some takeaways, and then come talk to us about why that's important or what else is important to you. So what makes Neo4j different? In the product team, we like to take on different perspectives, different personas, right? And you'll hear this term perspective sort of throughout in different contexts. So what makes Neo4j different? We can think of that in also different perspectives, right? So whose perspective do you want to take? Let's take a historian's perspective, right? So from a data historian standpoint, if I think about the term digital transformation that's thrown around quite a bit these days, what was digital transformation in 1979? I was 3 years old, so I don't really totally know what was going on, but there was a bunch of paper forms, and we were trying to get that information digitized into data that can be accessed by lots of different people in lots of different contexts. And then out of that came this technology called RDBMS. Probably everybody has heard of it now. And over the next couple of decades, obviously people were doing this over and over, to the point that now each of those dots that you see on this screen is probably a database in your enterprise that's connected somehow into your data pipelines, and data is flowing from one place to another place to another place. And now we're running into this digital transformation challenge of how do you run and work with connected data and these connections and finding these relationships with the current hardware that's available to us. And therefore, we think of Neo4j as one way that you can approach this problem of finding the connectedness in the data and exploring that connectedness and then getting value out of that connectedness. If we take a different perspective of an IT portfolio manager or CIO or whatever, I have tons and tons of different database systems available to me. What makes Neo4j useful for me? And so for those kinds of folks, as a PM, I have to think about, okay, how am I going to explain the differences? So if you think of traditional databases, the RDBMSs were initially meant to store data and retrieve data, right? You can also think of key value stores and document databases as one way of storing information and retrieving it. It's not really necessarily meant to do a lot of joining across. Definitely not necessarily at the time of writing that information. And then, of course, you have also data warehouses and columnar stores and big data these days with Hadoop and Spark and whatnot. And those are great for aggregation and filtering that looks across a lot of your data. And then you might be doing joining, but in the days of in today's date of Hadoop and Spark and whatnot, you're trying to denormalize as much as possible, so you limit that number of joins that happen across your data. But what Neo4j is really optimized for is this concept of connectedness and exploring hops, many degrees of hops and many number of traversals across your data. So again, we've heard of this quite a bit today. I'm not necessarily going to belabor that, and also not going to belabor a lot of this technical architecture pieces, but some takeaways again for you to take notes and then quiz us on later. What makes Neo4j different? Because we're storing the connections at the time that you're writing it, and therefore you don't have to load a bunch of things in memory and then do the join in memory. It's already there, and you can do those pointer changing operations based on how you're storing the data. And therefore, the performance curve that you have for graph data, specifically when you're exploring those hops and then hopping across your data, looks something like that. And those are the kinds of workloads that Neo4j and a graph database is great for. What makes Neo4j really special is the fact that from the beginning, we relied on ACID consistency in terms of how the database works. And so, if you think of clusters, the way that you store information on one node of your cluster, one instance of your cluster is exactly the same way as it's stored in every other place, every other instance. But in case of non-graph ACID DBMSs, the ones that think about eventual consistency and so on, may not actually be eventually consistent either, right? You may end up with broken relationships, you may end up with orphan nodes and so on and so forth. So ACID is really something that was very important to us and is part of our core architecture of Neo4j. Also, what makes Neo4j different is the cipher language that we use. So you heard Preston earlier today talk about these different hierarchies, systems sitting on systems, and trying to figure out those kinds of traversals. Like in my days in BI, in fact, I used to work for a company down the street, MicroStrategy. You may have heard of it for many years, and I was working a lot with our retail customers, and they had the same kinds of problems with BI tools running on relational databases, trying to do these hierarchy traversals 8 levels down, and trying to figure out this particular item, I'm going to filter over here, but I'm going to roll it up all the way up to the soft line or the hard line department, or whatever the hierarchy was called, and do joins along the way across my large high cardinality tables. And that was a really, really hard problem for them to solve as well. In this particular example, and writing those queries for the DBAs and for the BI analysts was really hard as well. In this particular instance, the thing on the left you can't really read is a SQL query for figuring out if I'm a manager, a boss of whatever, like I always dream of. If I look at my subordinates and their subordinates, maybe 3 levels down, and then I want to count who are their subordinates 3 levels down. So look at everybody in my hierarchy, and then 3 levels down, and then their subordinates 3 levels down. Just give me a count of how many people are reporting to these people, right? The left query is a SQL query. The right-hand side, the small box at the top, is a cipher query, which is equivalent to that. So obviously, one example may not be applicable all the time, but the idea is that the cipher language is really powerful in expressing what it is that you want to learn from your data, and being able to explore this connectedness concept is really powerful. So much so that in 2015, we made the cipher language an open source language that other people are adopted or have adopted and are also contributing to. I think we heard GraphAware talk about creating cipher extensions. So it's really powerful. And we also have the Spark ecosystem adopting cipher in 3.0 for graph workloads and graph queries in the Spark ecosystem. Not going to cover all of these, but here are some different foundational components. I mentioned a couple. Let me move on. And then not only what makes Neo4j different, but what also is needed that's not different across different database systems are all of these enterprise concerns around security, high performance, scalability of writes. How do you operate your database so that it can, you can do rolling upgrades on it without getting shutting your system down, or to do these auto cache warm-ups so that the performance to the users is really as they expect it to be. So thinking of all of those things has been in our DNA for many years now. And so there are many different kinds of consumers of data, right? Applications is one kind of consumer. Data scientists for doing hardcore analytics might be another kind of consumer. Business users would be another kind of consumer. There are different applications that graph databases are good for, Neo4j is good for. So we have to think about essentially all of those kinds of cases. And therefore, when we think of Neo4j as a database, it's not just a database. It's a data platform, and that's the way we approach it, a graph platform that's meant for not only storing information, but making sure that different kinds of users have access to, not only have access to, but different kinds of users can work with the entire database, and basically build an ecosystem around the core database. And so things like development administration, drivers, visualization tools, data integration, and so on and so forth. So I'm just going to go ahead and build this out. I think it's pretty hard to read, and the slides will be available to you guys. So here are all the things that we've just worked on in the last, I would say a few months. With our 3.5 release, with the 3.4 release before that, both of these releases came out in 2018. We're working on 4.0 this year. Some of the key highlights, I guess, would be, full text search ability that was added in 3.5. This change to native indexes that we have been working on since 3.2 of Neo4j, and slowly going into the different kinds of indexes that we make available. That has come to a finish almost with 3.4 and 3.5. The Cypher language is faster. Obviously, drivers keep getting enhanced as core database features keep getting enhanced as well. Improvements on the administration and operability side. And then the one thing that I really want to talk to you guys about is Neo4j Blue, right? My thing. You can ask me all kinds of questions about that. If you have questions about other sides of Neo4j, we have other experts in the room that can help you with that as well. So let's touch on Neo4j Bloom. Other than today, who has heard about Neo4j Bloom before you came here today? A few of you, maybe 25, 30% of you. Great. So before we touch on Neo4j Bloom, I also want to say, I think there were some questions around key lines today. Linkurious came up. There are many different choices you have for visualizing data out of Neo4j. Bloom is one of them, for sure. And it's designed to be an application for business users, something that's out of the box, something that is integrated into Neo4j, something that is provided by Neo4j. You can basically get started on it right away. But then there are other choices, Linkurious being one of them in terms of graph visualization solutions. It's a great partner of ours. We work with them all the time. And again, an out-of-the-box application. They also add other components, like their own server and so on. Definitely useful in other use cases. BI tools, you could essentially think of and we are asked about that all the time. It's a little harder because BI usually thinks of data as tabular, right? And so you have to then convert graph into some kind of a table format so that then the BI tools can access it. There's some options available there. And then visualization toolkits, which would be the D3 you may have heard of, or Keylines is a visualization toolkit which is more suited around graphs. Specifically, they have very good features around just graph access and APIs and even connectors. And then Viz.js is another tool, Sigma.js is another tool. But depending on what you're trying to do, depending on what kind of expertise you have, depending on what's your time to market going to look like, and what are the end users looking for, you have different choices. So when we come to Neo4j Bloom, like I said, something provided by Neo4j, very quick for you to get started, integrated and provided by us, and so it takes advantage of most, the latest and greatest available on the database. The way we think about Neo4j Bloom is you have a lot of these different, oops, went too fast. A lot of these different capabilities. So what are the core things that are sort of unique about Neo4j Bloom? One is this idea of a perspective. Again, using that term, but in a different context. The perspective in Neo4j Bloom is a business view of the graph that you're accessing. And I'll show that in a second. It's a search-first kind of an experience. So the business user, who's the main sort of persona that we're targeting, basically a non-technical user, somebody who may know Cypher, but may not want to work on Cypher all the time. They just want to type in a few things, maybe a natural language kind of a query, or maybe just a keyword search or something like that, and then just go directly at the graph. That's the kind of persona that Bloom is for. And so search first is the sort of experience we've designed it to be. It's a visualization tool, so it's obviously that's what it provides. But it's GPU accelerated because we've made it so that it can visualize thousands of nodes on your screen, and to be able to do that, you have to take advantage of modern technologies like the GPU. It's designed for exploration, so you should be able to move things around. It's not a static view, and you should be able to inspect your graph at a very detailed level, like individual nodes, individual relationships. Look at the properties, and then even be able to make some corrections as much as you may want to do in a UI-based paradigm. Make some small changes to the property values if you don't see them as correct, or if a relationship is missing, you might want to connect something, or if you want to flag a particular node, you can do that too. So that's the idea behind Bloom. To drill in a little bit into a couple of these features, and then we'll get into the demo. Graph perspectives. So like I said, it's business views that you can create off the graph for different kinds of users. So you could categorize, like you may have labels at the graph level, which are pretty diverse, or lots of them. You could decide to categorize some of them, roll them up into a category that is more friendly to the business user. You may want to call it something that is more friendly to the business user. You may want to hide certain things away. And you might hide because it's just extraneous information. The business user doesn't want to learn about it. You may hide it because it's PII and you want to not show it to the users, right? Whatever the case might be. It might be transient information, like sometimes it's there, sometimes it's not. You don't really want to see it in terms of analysis. And then these perspectives, once you create them, can then be shared with different users who are given maybe custom roles, so that you can then categorize, and let me actually show that as an example. So here is the data set I'm going to use for the demo. It's a very simplified financial services kind of data set. You have a customer, you have different kinds of accounts that the customer has, bank accounts, credit card accounts, loans. You have some personal information about the customer, like SSN, or phone number or address. And then you have transfers, money transfers or transactions that are in there. So if this is the graph that you're storing underneath, you could create a customer marketing perspective on the graph, and you hide away the transaction detail, and you hide away the PII that should not be visible, like social security number. And that's a customer marketing perspective. You may have a transaction analyst perspective who doesn't necessarily care about the customer, but cares more about the transactions and is looking for anomalies in the transaction. And therefore, you might hide some other parts of the data. You might be looking at a bank division perspective who can only see bank information, but cannot see credit card information or loan information, for example. So obviously, these are made up, but that's sort of the idea behind the perspective. So with graph searches, there are different kinds of things that from a user perspective, all you're doing is there's a search box, you're typing stuff in. But what's Bloom doing behind the scenes is it's trying to match that keyword that you're typing to many different things. It might be a label, so I don't know if it's very visible, but this thing, which is an unfilled box, is a label match. This is a category match. The categories that you've defined in the perspective, you can match against that. You can match against values in your data. This is the purple stuff that it belongs to some categories, and that is actually searching against your indexes, the property indexes. Or if you're typing in something longer, in this case, this might match what we call a search phrase, which might be a saved query, or it could be matching, a pattern, where a pattern is, between any connections between this category or that category, or a connection that goes through a particular kind of a relationship between different categories. So, or the last thing here is a full text search. You might also be, wanting to do a full text search against the database. And certainly with 3.5, we have a Lucene-based full text search, available on the database side, and therefore you could do that with Bloom. This is what the interface looks like. I'm just going to get to the demo in a second, but here are all the different kinds of things you could do. So that's the idea behind this kind of searching and visual exploration of Bloom. Couple other things I just want to talk about in the interest of time. So integrations. So Bloom as a visual UI is good. You can go in there, you can explore, but it also becomes more powerful when it's connected to some kind of a workflow that a user is taking on and using on a daily basis. In this particular example, on the top, and this is something that Gary Mann has built. He's here in the room and can talk more about. But it's an example of an application where people are exploring events on a dashboard, right? And the events are tied to global things that are happening all over the world. There's some protests happening, or other kinds of things happening, and we extract that data, run it through some NLP, do some sentiment analysis on it, and on the top you see a dashboard of where these events are happening, what kind of sentiment is associated with these events, and in that dashboard you might find some things that are interesting as a user to look at. Okay, great. Now, if you want to understand more details about that sentiment or the event or some kind of roll-up of what you're seeing in that data, you may want to then go into a graph exploration mode where you tie the event or the sentiment to what's the data underneath the covers that is associated with that particular event or sentiment. And with basically some deep linking capability that Bloom offers, you can essentially create these linkages where that application can then link to Bloom, and in Bloom the user can come in and then the search phrase that they wanted to type in was already populated, and then they can go about exploring the detail behind that particular event, that particular sentiment, or what have you. Obviously this is not just tied to this particular use case, but for any kind of use case. And then you can also control the perspective as you go in to Bloom to make sure that the perspective ties to the search that needs to be conducted. In terms of deployment, Bloom has a client piece and a server piece. The client piece is the thing where you actually do the layout and the visualization and the exploration. The server piece provides more procedures on the database side, also hosts Bloom in the next version of Bloom that's coming out shortly. And so you can have that server piece deployed just locally if you're using Neo4j Desktop as a developer, or on a server, Neo4j server, or a cluster. And then you have the Bloom client that you can run as an application inside of Neo4j Desktop, or you can also host it and then access it through the web browser. Host it on the server, access it through a web browser. So that's what is Neo4j Bloom. If you have questions, I'm not